In this notebook, I have did uh, code for the experiment data preprocessing. So first I imported required libraries such as pandas, matplotlib using the red CSV function. I have loaded the dataset into the data frame so that we can easily analyze and process the data. And for the second question, I calculated the percentage of missing values in the column. I used the eSnull function to identify the missing values and then calculating their percentage. This helps us understand which column contains missing data and how serious the issue is. And for the third question, for numerical columns with less than 10% missing values, I replace the missing values with the mean of the column. This is done because the mean represents the average value and helps maintain the distributions of the data. I perform this operation using a temporary data frame. And for the fourth question, interpolation estimates missing values based on nearby values. Here I used the nearest interpolation method, which fills the missing value with the closest available value in the dataset. This technique is useful when the missing values are small in number. And for the fifth question, for categorical columns, I replace missing values with the mode, which is the most frequently occurring value in that column. This approach ensures that the replacement value represents the most common category in the dataset. And for the sixth question, if a column has more than 10 percentage of missing values, it may reduce the quality of analysis. So I remove such columns using the drop function and then display the size to see how many columns remain. For the seventh question, outliers are extreme values that differ significantly from other observations. I calculated the set square for the column guarantee period. If the set square is greater than 3, the row is considered as outlier. These rows are removed to improve the reliability of the data set. And for the eighth question, duplicate rows occurs when all column values are exactly same. I used a duplicated function to find such rows and calculate their percentage in the data set. And for the ninth question, I checked for duplicates using only specific columns such as price, age, manufacturing month, fuel type. If rows have the same values in these columns, they are considered duplicates. These duplicates rows are removed and the updated data set size is displayed. And for the 10th question, min-max normalization scales numerical values between 0 and 1. I applied this technique to the quarterly tax column. This helps bring all values in the same range, which improves model performance and comparison between features. I also visualized uh, using a scatter plot. And for the 11th question, set score normalization transforms values based on the mean and the standard deviation of the column. This method converts the data into distribution with the mean 0 and the standard deviation as 1. I applied this normalization to the quarterly tax column and displayed the result using the scatter plot. And for the 12th question, I did a label encoding. Label encoding assigns a unique numerical value to the each category. For example, the column fuel type may contain categories like petrol, diesel, and CNG. Using label encoding, each category is converted into a number so that machine learning algorithms can process it. And for the last question, which is 13th question, I did one hot encoding, which converts a categorical column into a multiple binary columns. each category becomes a separate column with values 0 or 1. For example, fuel type, petrol, uh, diesel, and a fuel type CNG will be created. This method prevents algorithms from assuming an order between categories. Thank you.